Good morning, children. Today uh, we will continue the chapter electricity. Uh, a factor affecting resistance or of a conductor. Okay, but before I repeat, what is the Ohm's law? At a constant temperature, current flowing in a conductor is directly proportional to the potential difference applied across its end. V upon I is equal to R. So, R means the resistance. So, the factor affecting resistance R, and the first is on the length of the conducting wire. Okay, uh, the two wire of the different materials having same length and a cross section area has different resistance. Thus, the nature of the material is also decided the resistance. Okay. And so the first is on the length of the conducting wire length. Um Resistance of a uniform conductor is directly proportional to length of the conductor. R is proportional L. That is, more will the length. अगर length ज़्यादा होगी, then the uh, then the higher will be the resistance. Resistance भी ज़्यादा होगा. On the area of the cross section of the uh, conducting wire, uh, resistance of a uniform conductor is inversely proportional to its cross sectional area. R is equal to 1 upon A means cross sectional area. Okay. When the area of the cross section of the wire is double, then the resistance get half. And if the area of the cross section of a wire is half, then the resistance will be double. And the third is the material of the conducting wire. If the wire of the different material of the same length and the same area of the cross section are taken, then their resistance will be different. Okay. And the last is temperature. Resistance of the pure metal increase with increase in temperature, while resistance of carbon, semiconductors and the electrolytes decrease with increase in the temperature. Few alloys like constant and the manganese do not change their resistance appreciably for the range of temperature. This is the reason why we use these material as a resistance for many practical purposes. So, the resistivity is equal to R is equal to phi upon 1 upon L upon A. Unit of the specific resistance is ohm meter. Okay. Or rho is equal to R A upon L. So, the resistivity of a substance does not depend on its length or its thickness. It depends on the nature of the substance and the temperature. Uh, the different substance had the different resistivity, uh, and the alloy also alloy has the property that do not get oxidized easily at high temperature. Alloy, yes. And the resistive electricity and system of the resistor. Okay. First in combination of series in a combination of resistance in series. Okay. uh, in this combination, the second of each resistance is connected to the first end of the next resistance, so on. Thus the resistance are joined end to end as you show in the figure. It is clear that the same current flow in all the resistance, but the potential difference between their ends are different according to their resistance. Let's there are four resistance wire of the R1, R2, R3 and R4 are joined in a series. Suppose their equivalent resistance, that is a resistance wire we can be used in the place of all the four resistance, is capital R. If V1, V2, V3 and V4 are their potential difference. V4 are their potential difference between the end of the resistance. So according the Ohm laws, V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3 and V4 is equal to IR4. And we compare these, so we get R is equal to, so we get R is equal to R1 plus R2 plus R3 plus R4. Okay. So we can say that when the several resistors are joined in series, the resistance of the combination equal to the sum of their individual resistance, that is R1, R2, R3, R4, and thus the greater than any individual resistance. Resistors in parallel. Uh, in this combination, two or more resistance are combined in such a way that Their first ends are connected to one point and the second ends to another point. Thus potential difference between the ends of all the resistance is same, but the current is in different resistance are different. uh, the current I flowing from the cell is divided into the three parts and suppose I1, I2 and I3 are the current in the R1, R2 and I3 respectively. These three currents meet again at a point B from the main current. Thus we have I is equal to I1 plus I2 plus I3. Uh, Let the potential difference between the point A1 and and B be V. Since each resistance is connected between A and B, hence V will be the potential difference between the end of the each resistance. Therefore V is equal to I1 R1. uh, um, okay. uh, so I1 is equal to V upon R1, I2 is equal to V upon R2 and I3 is equal to V R3. And from equation 1 and 2, 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3.